there is a version of you that worked all night long. Not the version that tossed and turned. Not the version that checked the clock at 3 in the morning. But a deeper version. One that processed every difficult conversation you had this week. Rehearsed fears you haven't spoken aloud. And built entire worlds from fragments of memory while your body lay completely still. And sometimes, that version leaves you more tired than when you closed your eyes. Welcome to Sleep Science Documentary. Wherever you are right now, perhaps lying in the quiet dark, or feeling the familiar weight of a day finally ending, allow yourself to settle into this moment. We'll journey through 100 sleep science facts about dreams and the exhausted mind. From the deep biology of why your brain refuses to rest even in sleep, to the strange science of emotional processing that happens every night without your permission, to the moment researchers began to understand why some mornings feel heavier than the nights that made them. These quiet journeys through the science of the mind build a community of people who are learning to understand themselves more gently. A soft like, subscribe, or sharing this with someone who wakes up tired helps other sleepless souls find their way here and brings us closer to protecting this peaceful space. One sleepy soul at a time. Your presence here means more than you know. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You are floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Most people assume that sleep is simply the absence of waking life. But that assumption turns out to be beautifully wrong. Sleep is one of the most metabolically active states the brain ever enters. During a full night of sleep, your brain cycles through distinct stages of activity, some almost indistinguishable in energy use from full wakefulness. The idea that the mind goes quiet when the body rests is one of the most persistent and most incorrect beliefs in everyday science. What actually happens is something far stranger and far more purposeful than mere stillness. The sleep cycle repeats approximately 4 to 6 times each night, and each cycle lasts roughly 90 to 110 minutes. Within each cycle, the brain moves through lighter, non-REM stages, descends into deep, slow-wave sleep, and then rises back toward REM, the stage most associated with vivid dreaming. This rhythm is not random. It is orchestrated by a network of brain regions, hormones, and circadian signals working together in patterns that took millions of years of evolution to develop. The fact that this process sometimes leaves us exhausted suggests it is doing something far more demanding than resting. REM sleep, rapid eye movement sleep, was formally described for the first time in 1953 by graduate researcher Eugene Aserinsky and his advisor Nathaniel Kleitman at the University of Chicago. Their paper, published in the journal Science that September, described recurring periods of rapid eye movements during sleep, a pattern they found consistently linked to dream reports in the subjects they studied. Before this finding, the internal experience of sleep had been almost entirely invisible to science. That brief, 1.5-page report changed the field entirely and opened a century of questions we are still working to answer. During REM sleep, your brain becomes highly active. The regions responsible for visual processing, emotional regulation, and memory consolidation all show increased activity, sometimes matching or exceeding the patterns seen during focused waking thought. Meanwhile, the prefrontal cortex, the part of the brain most associated with rational decision-making and logical control, becomes significantly quieter. This combination creates a mental state unlike anything experienced while awake. Emotionally vivid, visually rich, and largely unfiltered by reason. Dreams are not random noise. They are the mind operating under a very different set of rules. One of the most intriguing features of REM sleep is a condition called REM atonia. During this phase, the brain actively sends signals to the spinal cord that temporarily paralyze the body's voluntary muscles. This is a protective mechanism. It prevents the physical body from acting out the movements happening in dreams. In most people, this paralysis is complete and seamless. But when it briefly fails upon waking, the result is the phenomenon known as sleep paralysis. The strange, sometimes unsettling experience of being conscious but unable to move, often accompanied by vivid sensory impressions. Estimates suggest that between 8 and 50% of people experience this at least once in their lifetime. The emotional content of dreams is not evenly distributed across the night. Early sleep cycles contain more slow-wave deep sleep and relatively brief REM periods. As the night progresses, REM periods grow longer and emotionally the most vivid and layered of the night. This means that the dreams closest to morning, the ones most likely to be remembered, carry the fullest emotional texture. When researchers at the University of California, Berkeley examined this pattern, they found evidence that the brain appears to use the earlier cycles for memory consolidation and the later cycles for something closer to emotional regulation, processing difficult experiences in a neurochemically unique environment. Stress changes the architecture of sleep in measurable ways. When cortisol, the primary stress hormone, is elevated at bedtime, the brain's entry into deep, slow-wave sleep is delayed. REM sleep arrives earlier and lasts longer than normal. This shift is sometimes called REM rebound, and it has a significant consequence. The brain spends more time in its most emotionally active state and less time in the deep restorative sleep that physically repairs the body, consolidates long-term memory, and clears metabolic waste. The result, experienced by millions of people every morning, is a particular kind of tiredness that rest alone cannot seem to fix. Dreams involving negative emotions are significantly more common than dreams involving positive ones. Research consistently shows that across cultures, ages, and sleep conditions, the most frequently reported dream emotions are anxiety, fear, and sadness. Happiness and joy appear, but less often. Some researchers interpret this as evidence that dreams serve a specific emotional processing function, that the dreaming brain preferentially works through threat, loss, and conflict rather than celebration. From an evolutionary perspective, this makes a certain quiet sense. The scenarios that most needed rehearsing were rarely the pleasant ones. The hippocampus, the brain region most involved in forming new memories, is highly active during both slow-wave and REM sleep. During slow-wave sleep, it appears to replay the day's experiences in compressed sequences, transferring information to the cortex for longer-term storage. During REM sleep, this process shifts. The hippocampus and amygdala, the brain's emotional processing center, become closely linked, and the dreaming mind begins weaving new experiences together with older memories in ways that are not strictly logical. This cross-referencing of old and new may be one reason why dreams feel simultaneously familiar and surreal. So why do some dreams leave us exhausted? The first part of the answer is emerging clearly from neuroscience. Dreaming is work. Not metaphorical work, but measurable neurological labor. The brain during vivid dreaming consumes significant energy, activates emotional processing regions at high intensity, and generates a kind of simulated experience that the nervous system responds to as if it were real. The body does not always know the difference between what happened in sleep and what happened in waking life. If the dream was frightening, the stress response was real. If the dream was grief-filled, the emotional weight was real. The exhaustion that follows is the after effect of that reality. The amygdala, a small almond-shaped structure deep in the brain, plays a central role in emotional dreaming. During REM sleep, the amygdala is 2 to 3 times more active than during calm wakefulness. It processes threat, fear, and emotional salience. And during dreams, it does so without the moderating influence of the prefrontal cortex. This means that during REM sleep, the brain is running its most sensitive emotional recognition systems at elevated intensity, without the rational oversight that normally helps regulate those signals. The dreaming mind feels deeply, without necessarily understanding why. Nightmares are more than unpleasant memories of sleep. They are classified by sleep researchers as distinct from normal anxious dreams, defined by their intensity, the emotional weight they carry, and their tendency to cause waking. Approximately 50 to 80% of adults report having nightmares, at least occasionally. Approximately 5 to 8% of the general adult population experiences frequent nightmares, defined as 1 or more per week, at a level that affects daily well-being. In populations experiencing post-traumatic stress, that rate rises significantly. Frequent nightmares are now gently acknowledged by sleep medicine as something worth tending to, with care and understanding. The neuroscience of nightmares reveals something worth understanding calmly. During a nightmare, the brain activates the same regions that respond to real danger. Heart rate increases. Breathing becomes shallower. Cortisol and adrenaline are released into the bloodstream. The body enters a state of heightened alertness, physiologically similar to waking activation, all while lying completely still in bed. When the nightmare ends, whether through waking or natural transition, the body must then regulate these hormones back to baseline. This regulation takes time and energy. It is one of the clearest explanations for why a difficult night of dreaming leaves the waking body feeling used. Sleep researchers have identified a condition called dream enacting behavior, which occurs most commonly in a disorder known as REM sleep behavior disorder. In this condition, the muscle paralysis that normally characterizes REM sleep is incomplete or absent. Affected individuals may talk, shout, or physically move in ways that mirror the content of their dreams. This condition, more common in older adults and studied in connection with certain neurological changes, offers unusual evidence about the relationship between the dreaming brain and the body. It demonstrates that the brain's dream activity is not passive. It generates genuine motor commands. The atonia of normal REM sleep is the only thing that prevents those commands from becoming physical actions. The content of dreams is influenced by waking emotional state in ways that neuroscientists are beginning to map with increasing precision. Research published in Nature Communications found that the emotional tone of dreams correlates with the activation patterns of the medial prefrontal cortex during the hours before sleep. Put simply, the emotional experiences of the previous day are not left at the door when we sleep. They are carried in, processed through the night's architecture, and sometimes returned to us in the morning in forms we barely recognize. The emotional residue of a difficult day often becomes the raw material of a difficult night. Slow-wave sleep, also called deep sleep or stage 3 non-REM sleep, is the phase most associated with physical restoration. During this stage, the body releases growth hormone, the immune system activates repair processes, and the glymphatic system, a network of fluid channels in the brain, clears metabolic waste products. When this phase is shortened or disrupted, the physical consequences are measurable. Muscle recovery slows, immune response weakens, and the brain accumulates slightly more of the cellular debris that builds during waking activity. Deep sleep is the body's most efficient maintenance window, and its absence leaves a trace that the morning body can feel. In 2012, neuroscientist Maiken Nedergaard and colleagues at the University of Rochester described what they called the glymphatic system, a previously unknown network of fluid channels in the brain that clears metabolic waste. A follow-up study in 2013 found this system nearly 10 times more active during sleep than during wakefulness, at least in mice. Most of what we know about glymphatics comes from animal studies, though research published in late 2024 offered the first direct observations consistent with this system in the human brain as well. The clearance process appears to be especially tied to slow-wave deep sleep, when the brain's cells contract slightly, allowing cerebrospinal fluid to wash more freely through the tissue. When deep sleep is insufficient, whether due to stress, sleep difficulties, or fragmented nights, the glymphatic clearing process is incomplete. This means that a brain chronically deprived of sufficient slow-wave sleep is a brain that begins each day carrying slightly more of the previous day's metabolic burden. Over time, this accumulation has real consequences. But on a single difficult night, the immediate effect is subtler and more familiar. The heaviness of thought, the slight difficulty with focus, the sense that the mind is working harder than it should to do things that normally feel effortless. This is what inadequate deep sleep feels like from the inside. Stress and dreaming are connected through a specific hormonal pathway involving the hypothalamic pituitary adrenal axis, the body's main stress response system. When this axis is activated by stress, the resulting hormone cascade suppresses slow-wave sleep and increases REM density. But the consequences extend beyond that single night. A brain that has spent the night in elevated emotional processing wakes with reduced capacity to regulate the emotions it encounters during the day. That reduced resilience then makes the following day harder to navigate, which, in turn, creates the conditions for another difficult night. The biology of stress and the biology of disturbed dreaming share the same underlying circuitry, and they tend to amplify each other quietly over time. Research published in the journal Sleep found that people who reported higher levels of daily stress showed significantly greater next-day fatigue when their sleep included high levels of emotional dream content. This relationship held even when total sleep duration was controlled for, meaning that it was not simply how long they slept that determined how rested they felt, but the emotional character of the sleep they had. This finding has important implications. It suggests that measuring sleep quality only in terms of hours misses a dimension that the body tracks very carefully. The quality of the dreaming mind is as relevant as the quantity of time spent in bed. Dream recall varies considerably among individuals and is itself shaped by sleep architecture. People who wake during or immediately after REM sleep are far more likely to remember their dreams than those who wake from slow-wave sleep. This means that frequent nighttime awakenings, which are common in people with anxiety, stress, or certain sleep difficulties, tend to produce higher rates of dream recall. And higher dream recall, particularly of emotionally negative dreams, correlates with increased morning fatigue and reduced mood. The gentle irony is that the people most likely to remember their dreams are often the ones for whom dreaming has been most demanding through the night. One theory that has gathered significant attention in recent years is the threat simulation theory of dreaming, proposed by Finnish neuroscientist Antti Revonsuo. This theory suggests that dreams, particularly those with threatening content, serve an evolutionary function by allowing the brain to rehearse responses to difficult situations in a safe, offline environment. In this framework, the emotional intensity of threatening dreams is not a problem but a purpose. The unease felt during a nightmare is the emotional equivalent of a practice run. The brain is rehearsing, and like all rehearsal, it costs something. The tiredness that follows may be the physiological price of that preparation. The role of the prefrontal cortex in dreaming has been a source of particular scientific interest. During REM sleep, this region, which governs self-awareness, logical reasoning, and emotional regulation, shows reduced metabolic activity in most people. This reduction is thought to explain several characteristic features of dreaming: the acceptance of impossible events, the blurring of identity, and the inability to recognize that one is dreaming. In lucid dreamers, people who become aware they are dreaming while still asleep, partial reactivation of prefrontal regions has been observed, suggesting that the boundary between dreaming and waking cognition is not absolute, but a matter of degree. Lucid dreaming is not merely an interesting curiosity. It is a measurable neurological state in which the dreamer achieves metacognitive awareness, the ability to observe the dream from within it. Research teams working independently across 4 institutions in the United States, France, Germany, and the Netherlands successfully communicated with lucid dreamers in real time during verified REM sleep. Their work, published together in Current Biology in February 2021, showed that a dreaming person can hear a question, process it, and signal a response using eye movements or facial muscles, all without waking. Correctly answered questions were recorded on 29 occasions across 6 participants. Conscious awareness, it turns out, does not fully disappear during sleep. By now, the outline of an answer to the video's central question is already visible. Waking up exhausted after dreams is not a mystery of the body failing to rest. It is the predictable consequence of a brain that worked intensely through the night, processing emotional residue, consolidating memory, rehearsing responses to difficult scenarios, and conducting biological maintenance, all while the conscious self was absent. These patterns are emerging with increasing clarity in the scientific literature. The exhausted morning is not a sign that something went wrong. It is often the afterimage of a night during which something very demanding went right. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of processes working in silence. Heart beating, lungs breathing, brain sorting through the day's experiences, all without your command. Notice the gentle sensations along your spine, in your shoulders, behind your eyes. Right now, without your awareness or effort, your brain is beginning its nightly work. The first cycles are already preparing. You are a complete system, diverse, self-sustaining, and remarkably wise in its silence. Now we continue. The relationship between emotional processing and sleep is bidirectional. Poor sleep worsens emotional regulation during waking hours, and heightened emotional states worsen sleep quality at night. This creates a cycle that researchers have described as a self-reinforcing loop. A difficult day produces fragmented, dream-heavy sleep. That sleep produces reduced emotional resilience the following day, which produces another difficult day. Understanding this loop is not discouraging. It is clarifying. It reveals that the entry point for change can be at either end. The concept of sleep pressure, the biological drive to sleep that builds during waking hours, is regulated by a molecule called adenosine. As neurons fire throughout the day, adenosine accumulates in the brain, creating increasing sleepiness. Sleep clears adenosine, resetting the pressure to near zero by morning. Caffeine works by blocking adenosine receptors, temporarily masking the signal without reducing the underlying accumulation. This is why caffeine borrowed from tomorrow's wakefulness must eventually be repaid. It also helps explain why a night of poor sleep does not fully reset the pressure. The adenosine clearance is incomplete when sleep architecture is disrupted. Heart rate variability, the slight variation in time between heartbeats, is now widely used as a measure of autonomic nervous system recovery during sleep. High heart rate variability during sleep indicates that the parasympathetic nervous system, the rest and digest system, is dominant, and that the body is in genuine recovery mode. Low heart rate variability, particularly during periods that should correspond to deep sleep, suggests the stress response system remains partially activated. Wearable devices that track heart rate variability during sleep are now providing large-scale evidence that dream-heavy, emotionally demanding nights consistently correlate with lower recovery scores. Even when total sleep time appears adequate, the architecture of a single night's sleep tells a story in structure. Healthy sleep in a non-stressed individual shows a predictable pattern. Longer periods of deep sleep in the first half of the night. Longer periods of REM sleep in the second half. With each REM period growing progressively longer. In chronically stressed individuals, this architecture is often compressed or altered. Deep sleep is shortened. REM appears earlier. The transition between stages becomes less distinct. Sleep researchers refer to this altered pattern as fragmented sleep architecture, and it is one of the most consistently documented findings in the sleep science of stress and emotional exhaustion. Emotional memory consolidation during sleep is not simply a recording process. It is a selective, transformative one. Research led by neuroscientist Matthew Walker at the University of California, Berkeley, has proposed that REM sleep strips the emotional charge from difficult memories while preserving their factual content. In this model, we wake the next morning remembering what happened, but feeling somewhat less raw about it than we did the night before. When this process works, sleep functions as a form of overnight emotional softening. When it is disrupted, when stress or fragmented sleep interferes, the emotional weight of difficult memories is preserved alongside their content. The morning carries the full load. The neurotransmitter norepinephrine, a chemical closely associated with the stress response, reaches its lowest levels in the brain during REM sleep. Some researchers believe this reduction is not incidental but functional. The decrease in norepinephrine may be precisely what allows the dreaming brain to replay emotionally charged memories without triggering the full physiological stress response. In this view, REM sleep is a neurochemically protected space for emotional processing, a window during which the brain can examine difficult experiences without being overwhelmed by them. When stress keeps norepinephrine elevated during sleep, that window narrows, and the emotional processing becomes less complete. Post-traumatic stress offers a window into what happens when the dream-based emotional processing system becomes stuck. In PTSD, the nighttime replaying of difficult memories, often experienced as nightmares, occurs without the norepinephrine reduction that normally makes REM processing gentle. The emotional tone of the original experience is preserved and reactivated with each replay. Rather than gently softening the memory, the dreaming brain returns to it repeatedly, in a loop that has not yet found its release. Treatments that specifically target sleep and nightmares, including image rehearsal, therapy, and certain medications, have shown real effectiveness precisely because they address this underlying process, helping the loop gradually find a different ending. The term sleep quality is more nuanced than it first appears. Researchers typically assess it across multiple dimensions. Sleep onset latency, meaning how long it takes to fall asleep. Sleep efficiency, the ratio of time asleep to time in bed. Number of nighttime awakenings, time spent in each sleep stage, and subjective ratings of how rested one feels upon waking. Of these measures, subjective morning restedness, how you actually feel when you open your eyes, is increasingly recognized as a meaningful signal in its own right. It reflects the integrated experience of everything the sleeping brain did through the night. Dreaming appears to have a role in creative problem-solving that goes beyond simple memory consolidation. Neuroscientist Ulrich Wagner and colleagues at the University of Lübeck found that subjects who slept between an initial learning session and a later test were nearly 3 times more likely to discover a hidden shortcut within a mathematical task. Around 60% of the sleep group found it, compared to roughly 22% of those who remained awake. Later researchers found the effect varied across age groups and conditions, but the pattern has held consistently enough to suggest that sleep reorganizes learned material in ways that waking thought rarely manages on its own. The dreaming brain, freed from the constraints of logical sequence, finds connections the waking mind tends to miss. Some dreams are mundane, some are surreal, and some carry an emotional weight so specific and so accurate that waking from them feels like waking from a second life. Research into what makes certain dreams memorable has converged on a consistent answer: emotional intensity. The amygdala's activity level during a dream predicts how well that dream will be remembered. This means the dreams that stay with us, the ones that color the morning and linger through the afternoon, are specifically the ones that activated the brain's emotional systems most fully. Memory and emotion in the dreaming brain are not separate systems. They are deeply, structurally entangled. Temperature plays a subtle but measurable role in sleep quality and dreaming. The body's core temperature naturally drops by 1 to 2 degrees Fahrenheit during sleep, and this drop is one of the signals that initiates and maintains sleep architecture. A room that is too warm interferes with this thermal regulation, suppressing slow-wave sleep and increasing REM density and fragmentation. Studies have consistently found that warmer sleeping environments produce more unsettled, dream-heavy sleep and lower morning restedness ratings. The ideal sleep temperature for most adults falls somewhere between 60 and 67 degrees Fahrenheit, a range that allows the body's natural cooling process to proceed without resistance. The relationship between alcohol and sleep is one of the most misunderstood in everyday knowledge. Alcohol does help most people fall asleep faster. It suppresses REM sleep in the first half of the night, producing what feels like deeper initial sleep. But as alcohol is metabolized in the second half of the night, REM rebound occurs. REM sleep surges, often with vivid dream content, and sleep becomes fragmented and shallow. The person who drank to sleep better often wakes feeling less rested than if they had simply lain awake. The apparent sedation of alcohol is borrowed against the sleep quality it quietly removes in the early morning hours. Napping, when timed and structured appropriately, can partially restore the cognitive performance lost to a disturbed night without deepening sleep debt or disrupting nighttime sleep. A nap of 20 to 30 minutes taken in early afternoon, before 2 in the afternoon for most people, allows the brain to enter light NREM sleep and partially replenish adenosine clearance. Naps longer than 30 minutes risk entering slow-wave sleep, which produces sleep inertia upon waking. The groggy, disoriented feeling of being pulled from deep sleep too early. For someone whose nights have been filled with emotionally demanding dreams, a brief afternoon nap is one of the gentler tools available for partial recovery. The circadian rhythm, the roughly 24-hour internal clock that governs sleep-wake cycles, is regulated primarily by a small cluster of neurons in the hypothalamus called the suprachiasmatic nucleus. This nucleus receives direct input from light-sensitive cells in the retina, which is why light exposure is the most powerful external regulator of the body clock. Morning light advances the clock, making sleep onset earlier that night. Evening light delays it, pushing sleep later. The timing of sleep, relative to the circadian rhythm, affects not only when we sleep, but how deeply we sleep and how emotionally active our dreams become. A body sleeping against its own internal clock sleeps less efficiently. We are now at the midpoint of the early section of this journey. What the science is beginning to show, across all of these different threads, is that the exhaustion some people feel after dreams is not one thing. It is the convergence of several things. Elevated stress hormones that alter sleep architecture, an emotionally active dreaming brain working at genuine intensity, incomplete deep sleep restoration, disrupted glymphatic clearance, and a morning nervous system that has not yet fully settled from the night's physiological demands. Understanding these mechanisms does not make the tiredness disappear, but it begins to make it meaningful, which is a different kind of relief. Take a slow breath. Notice how your shoulders have settled just slightly since we began. We're exploring the science of something you've lived through. Those heavy mornings. Those dreams that stayed too long. You and I, and everyone listening quietly in the dark. There's no rush. No destination. Just the gentle unfolding of understanding, carrying us forward. Let's continue. The concept of sleep homeostasis, the body's tendency to compensate for lost or disrupted sleep, reveals something interesting about recovery. After a night of poor sleep, slow-wave sleep pressure increases on the following night. The brain prioritizes physical restoration first. REM sleep recovery tends to follow in subsequent nights. This sequential recovery means that a single difficult night of dreaming is not necessarily fully resolved the following night. The body addresses physical repair first, emotional processing second. For people under ongoing stress, this recovery sequence is perpetually interrupted before it completes, creating a rolling deficit of emotional sleep. Body movement during sleep, measured through a technique called actigraphy, is a reliable indicator of sleep quality and dream intensity. Periods of motor restlessness during sleep correspond to lighter sleep stages and emotionally active dreaming. People who report waking up exhausted from dreams often show actigraphy patterns consistent with frequent brief awakenings throughout the night, even if they do not consciously recall those awakenings. This phenomenon, called microarousal, interrupts the continuity of sleep architecture in ways that leave a real physiological signature on the waking body without necessarily producing a conscious memory. The default mode network, a set of brain regions that activates when the mind wanders during wakefulness, shows a distinctive activity pattern during REM sleep. It is engaged, but in a way that differs from simple mind-wandering. The dreaming brain's default mode network processes self-referential information, narrative construction, and social and emotional scenarios with a depth and integration that daydreaming rarely achieves. Some researchers have described REM sleep as a period of deeply personalized narrative processing, the brain writing and revising the story of itself, night after night, below the threshold of conscious observation. One area of sleep research focuses on what happens in the minutes immediately before sleep, the hypnagogic state. This transitional period between wakefulness and sleep is characterized by brief, involuntary sensory experiences, flashes of imagery, sounds, or physical sensations that arise without conscious intention. Electroencephalogram recordings during this period show a progressive slowing of brainwave activity from the alpha waves of relaxed wakefulness toward the slower theta waves of early sleep. The hypnagogic state appears to be a preparatory phase in which the brain begins transitioning its processing toward the emotional and associative mode of dreaming. What settles gently in the mind in those final moments before sleep may quietly shape what follows. The role of the thalamus in dreaming is both a gateway and a gatekeeper. During wakefulness, the thalamus acts as a relay station, filtering and forwarding sensory information to the cortex. During REM sleep, its role shifts. Sensory input from the outside world is largely blocked, a process called thalamic gating, while internally generated signals from the limbic system and brainstem are allowed to flow freely to the cortex. This is why dreams feel so convincingly real. The same cortical regions that process actual sensory experience are receiving signals. Just signals generated internally rather than externally. The dreaming brain is not imagining. It is perceiving a different kind of reality, created from within. Recurring dreams are a phenomenon reported by a substantial portion of the adult population. Estimates range from 60 to 75%. These dreams, which may repeat the same scenario with minor variations over months or years, appear to be connected to unresolved emotional material. Research suggests that recurring dreams often diminish or stop when the underlying emotional concern is addressed, whether through reflection, life changes, or the natural passage of time. They are not random loops in the brain's programming. They appear to be the mind's way of returning, persistently, to something that remains unprocessed. The repetition is the signal. The content of dreams is influenced by physical sensations during sleep in ways that have been studied carefully. A full bladder can generate dreams involving water or searching for familiar spaces. Sleeping in a cold room may produce dreams of being outdoors in winter. This incorporation of physical experience into dream narratives is called dream incorporation, and it demonstrates that even during REM sleep, when external sensory input is largely reduced by thalamic gating, some signals continue to reach the dreaming brain. The border between the body and the dream is more permeable than the experience of waking would suggest. Research on the effects of meditation and mindfulness practice on sleep quality and dreaming has produced a consistent finding. Regular meditators show altered sleep architecture compared to non-meditators. Several studies have found increased slow-wave sleep, reduced nighttime cortisol, and lower rates of nightmare frequency in long-term meditation practitioners. The proposed mechanism involves the prefrontal cortex, which is strengthened through meditation practice and which, even during sleep, may maintain slightly greater modulatory influence over the amygdala. This does not mean meditation makes dreams disappear. It appears to make the dreaming brain's emotional processing somewhat more gentle, and the mornings somewhat more settled. Sleep spindles, brief bursts of synchronized neural oscillation that appear in the sleep electroencephalogram during stage 2 non-REM sleep, are increasingly recognized as markers of sleep quality and cognitive health. Higher spindle density correlates with better memory consolidation, greater emotional resilience, and notably, reduced susceptibility to next-day stress reactivity. People who generate more spindles during sleep tend to wake up better equipped to navigate emotional challenges. Sleep spindle generation decreases with age and is reduced in several mood and anxiety conditions. Research is exploring whether spindle activity can be supported through behavioral and lifestyle interventions. We're at the halfway point of this journey. The question at the center of this video, why you wake up exhausted after dreams, has been approached from many angles now. The answer is becoming clearer. Dreaming exhausts because it is emotionally real. It exhausts because it engages the full machinery of the emotional brain at high intensity, without the physical movement or the social context that would otherwise help process those emotions. It exhausts because stress disrupts the architecture that would otherwise make it restorative. And it exhausts because the body does not fully distinguish between what it experienced and what it dreamed. The line, it turns out, is far thinner than we assumed. And imagine, for a moment, that every feeling you've ever processed in sleep is still somewhere inside you, transformed, softened, integrated, not gone, simply quieter. Each night, your brain has been working on your behalf, in silence, doing what no amount of waking thought quite manages. Right now, that process is beginning again. You don't need to direct it. You don't need to understand it. It already knows what to do. And we continue the journey. The relationship between sleep and the immune system is more intimate than most people realize. During slow-wave sleep, the immune system releases cytokines, small signaling proteins that coordinate immune responses. Some of these cytokines, including interleukin-1 and tumor necrosis factor, also promote deeper sleep. This bidirectional relationship means that illness makes us sleepy, partly because the immune chemicals fighting infection also deepen sleep, maximizing the restoration window. Conversely, poor sleep reduces immune effectiveness and creates mild inflammatory states that contribute to the morning heaviness, sometimes mistaken for pure tiredness. The ache of a difficult night is not only in the mind. Prospective memory, the ability to remember to do things in the future, is one of the cognitive functions most sensitive to sleep disruption. After a night of emotionally demanding dreaming, people show measurable declines in their ability to hold intentions in mind across delays. This may partly explain the experience of foggy mornings after difficult nights. Not only is recall of past information slightly softened, but the mental scaffolding for the day ahead, the internal arrangement of intentions and plans, is less stable. The mind that dreamed heavily often begins the day in a state of subtle disorganization. The science of social dreaming, how our relationships appear and are processed in dreams, is a growing area of research. Studies consistently show that the most common characters in dreams are known people, family members, friends, colleagues, and those we care about. The emotional quality of those dream interactions, whether they are warm, conflicted, distant, or tender, correlates with the emotional tone of the waking relationship. Dreams do not merely replay social experiences. They appear to process the emotional dimensions of attachment and connection in ways that influence how those relationships feel upon waking. A dream of loss can produce genuine grief. A dream of reunion can produce genuine ease. Children dream differently than adults. Before the age of 7 or 8, dreams tend to be relatively simple, more like single images or brief scenes than the complex narratives of adult dreaming. The emotional range of children's dreams is narrower, and challenging content is less common. As the brain matures through adolescence, dream complexity and emotional depth increase substantially. This developmental trajectory suggests that the capacity for emotionally rich, narratively complex dreaming is tied to the maturation of brain regions involved in self-awareness, social cognition, and emotional regulation. The full dreaming mind, in many ways, is the signature of a fully developed one. Older adults show changes in sleep architecture that affect both dreaming and morning restedness. Slow-wave sleep decreases substantially with age. By the 60s, many people generate only a fraction of the slow-wave activity they produced in their 20s. REM sleep is somewhat preserved but may become more fragmented. The result is a shift in the balance of sleep. Less deep physical restoration, relatively more lighter sleep, and dreaming. This is one reason why older adults often report feeling they sleep lightly, dream often, and wake feeling less refreshed than they did decades ago. The architecture itself has changed, and the experience reflects that change accurately. Exercise influences sleep architecture in ways that directly affect morning restedness. Regular, moderate aerobic exercise, even a daily walk of 30 minutes, has been shown to increase slow-wave sleep, reduce sleep onset latency, and improve subjective sleep quality. The mechanism involves both direct effects on adenosine accumulation and indirect effects through the regulation of cortisol rhythms. Interestingly, the benefits of exercise on sleep quality are cumulative and take several weeks to fully manifest. A single day of activity has a modest effect. A month of consistent movement shows significantly larger improvements in deep sleep and morning restedness. Light and its role in dreaming goes beyond simply setting the circadian clock. Blue wavelength light, the kind emitted by screens and many indoor lights, suppresses melatonin production and delays sleep onset. Research suggests that evening blue light exposure may also alter the emotional content of subsequent dreaming. Subjects exposed to blue light within 2 hours of sleep reported higher rates of emotionally unsettled dream content and lower morning mood ratings. One proposed pathway involves the light-sensitive cells in the retina that project directly to the amygdala, potentially shaping emotional responsivity before sleep even begins. The social jet lag phenomenon, the misalignment between the body's natural sleep timing and the schedule imposed by work and social obligations, is now recognized as a contributor to ongoing sleep disruption. People whose natural sleep phase is later than their required wake time accumulate sleep debt across the work week and attempt to recover on weekends. This irregular pattern disrupts sleep architecture, increases REM density during recovery nights, and is associated with higher rates of dream-related fatigue. The body does not simply store sleep deficit. It stores it in ways that alter the quality and character of subsequent sleep. The phenomenon known as sleep paralysis, those vivid, sometimes unsettling experiences of presence or pressure felt during the transitional moments of sleep, onset or waking, is now understood as a form of dream intrusion into waking consciousness. The brain's REM-generating systems activate briefly while the body is still in a state of muscular atonia, producing dreamlike imagery in a waking perceptual field. Across cultures and throughout history, these experiences have been interpreted as supernatural encounters. The neuroscience is far less dramatic, and in some ways more elegant. The boundary between dreaming and waking is not a wall. It is a permeable threshold. The question of whether animals dream is one that science has approached with increasing confidence in recent decades. Electroencephalogram recordings from sleeping birds and mammals show sleep stages analogous to REM sleep, complete with characteristic eye movements, muscular atonia, and brainwave patterns similar to waking activity. Rats, when allowed to run a maze and then sleep, show hippocampal replay patterns during sleep that correspond spatially to the maze's layout, effectively replaying the day's navigation. Dogs and cats frequently show physical movements during sleep, consistent with dreamlike activity. The dream, in some form, appears to be an ancient and broadly conserved feature of complex nervous systems. The science of dream therapy, using the content of dreams as material for psychological reflection, has ancient roots but modern validation. Cognitive image rehearsal therapy, developed for nightmare conditions, involves asking people to recall a recurring nightmare and then consciously rewrite its ending during waking hours, rehearsing the new version mentally before sleep. Clinical trials have shown this technique reduces nightmare frequency and emotional weight in both general populations and those carrying difficult histories. The brain, it appears, is genuinely open to narrative revision, even for stories it writes in sleep. What is gently rewritten in waking can quietly change what is dreamed. Certain medications alter dream content and intensity in predictable ways. Antidepressants that work through serotonin reuptake inhibition suppress REM sleep during the period of active use and produce REM rebound upon discontinuation, often with vivid and emotionally full dreaming. Some medications used for blood pressure can cross the blood-brain barrier and produce vivid dream experiences. Melatonin, taken in higher doses, increases REM density and dream recall. These pharmacological effects are not simple side effects. They are windows into the neurochemical machinery that governs the dreaming brain's intensity and reach. The concept of dream work, as distinct from sleep work, describes the neurological labor specifically associated with REM sleep processing. Researchers estimate that during a vivid dream, the brain generates neural activity equivalent in complexity to that seen during an engaging waking experience. The emotional simulation is metabolically real. The narrative construction is neurologically real. The social processing is functionally real. What is absent is the physical output, the movement, speech, and response that would normally accompany such experiences. The energy cost of dreaming is borne entirely internally, which is one reason why a dream can feel as exhausting as the waking experience it resembles. The role of the anterior cingulate cortex in dreaming has attracted research attention for its dual role in emotional processing and social sensitivity. During REM sleep, this region is active and appears to process the emotional significance of dream events. This region also processes social pain, the emotional weight of disconnection, unresolved conflict, or feelings of loss. This overlap may explain why dreams involving difficult relationships can produce physical sensations of heaviness upon waking, a weight in the chest, a dull quiet behind the eyes. The emotional and physical are not cleanly separated in the brain's architecture, and the truth shows most clearly in what we feel when we first wake. We are moving now into the phase where the science becomes something quieter, not less true, but less urgent. The facts ahead are simpler, and the language softer. By this point in the journey, what began as a question, why does dreaming exhaust us, has become something closer to a map. The exhausted morning is not a failure. It is evidence. Evidence that the brain took the night seriously, that it processed what needed processing, that it gave its full attention to the invisible maintenance of a life. That understanding, sitting quietly in the body as you settle deeper into rest, is worth something. Sleep and identity are connected in ways that science is only beginning to articulate. The stories we tell about ourselves, who we are, what we value, what we carry, are rehearsed and gently revised during sleep in the narrative processing of dreaming. People who sleep poorly for extended periods often report a vague sense of disconnection, as if each day begins slightly out of alignment with the one before. The dream is part of what makes the self feel continuous, the quiet thread connecting one version of you to the next. The science of self-compassion has its own evidence base in the sleep literature. Studies have found that individuals who respond to sleep difficulties with self-criticism show higher physiological arousal and poorer sleep quality than those who respond with acceptance and gentleness. The mind that criticizes itself for not sleeping well becomes more activated, not less. The mind that acknowledges the difficulty without judgment creates the conditions in which rest becomes possible. Sleep science and psychological science converge on the same quiet conclusion. Kindness toward the sleepless self is not indulgence. It is part of the path toward rest. Body scan techniques, the practice of moving slow, deliberate attention through different regions of the body, have been validated as gentle interventions for sleep onset difficulty. The mechanism involves the gradual quieting of the default mode network's narrative activity and the transfer of attention away from thought and towards sensation. This shift mirrors the natural attentional transition that accompanies early non-REM sleep, making it easier for sleep to follow. It is not a trick. It is a gentle alignment of deliberate attention with the direction the brain is already trying to move. The phenomenon known as pre-sleep cognitive arousal, the circling thoughts that can delay sleep, has a distinct neural signature. It involves activation of regions associated with self-referential processing in patterns that are physiologically different from the quieter brain states sleep needs. Cognitive behavioral therapy for insomnia, known as CBTI, directly addresses this state through techniques including stimulus control, sleep restriction, and gentle cognitive restructuring. CBTI is now recommended by sleep medicine guidelines as the first-line approach for ongoing sleep difficulty, with more lasting effects than medication alone for most people. The dream self, the version of you that appears as protagonist in your own dreams, is a fascinating neurological construct. Research into the phenomenology of dreaming suggests that dream self-identity is maintained through overlapping regions of the prefrontal cortex and the parietal lobe that also generate waking self-representation. The dream self feels continuous with the waking self. acts from recognizable motives, and responds to dream events with consistent emotional reactions. Yet, it accepts impossible premise, forgets recent waking memories, and rarely questions its own existence. This selective coherence is one of the most quietly intriguing features of the dreaming mind. The timing of dreams within the night affects not only their emotional content, but their cognitive character. Early night dreams, arising from shorter REM periods, tend to reflect recent daily experience. Familiar fragments woven together in recognizable patterns. Late night dreams, arising from longer REM periods, show greater incorporation of older memories, greater narrative complexity, and more emotionally layered scenarios. The progression from early to late night dreaming is itself a journey, from the surface of the day toward the deeper, accumulated material of a life. What seems to settle most deeply in our dreams is often not what happened yesterday, but what is still finding its way toward resolution. The practice of keeping a dream journal, writing down dream content in the first moments after waking, has several effects documented in the research literature. It increases dream recall over time, which can be both illuminating and, for those with frequent, unsettled dreams, initially challenging. It also provides material for reflection that sometimes reveals patterns the waking mind had not consciously noticed. What the dreaming mind returns to, again and again, is rarely accidental. The journal simply makes the pattern visible enough to be seen. The relationship between ongoing discomfort and disturbed dreaming is well documented. Physical discomfort disrupts slow-wave sleep, increases nighttime awakening, and can produce dream content reflecting the body's state. This creates a reinforcing pattern. Discomfort disrupts sleep. Disrupted sleep lowers the body's tolerance for discomfort, and lower tolerance makes sleep harder still. Research has found that improving sleep quality can soften the experience of the following day. The body that slept well carries its burdens more lightly. Addressing sleep is not separate from addressing well-being. It is one of the most direct paths toward it. The concept of allostatic load, the cumulative physiological weight of ongoing stress on the body, includes sleep disruption as a core element. Persistent sleep difficulty raises resting cortisol, influences inflammatory markers, and affects the body's regulatory systems in ways that accumulate quietly over months and years. The exhaustion felt after many successive nights of dream-heavy, stress-disrupted sleep is not only the tiredness of a difficult week, it is the signal of a body carrying more than its systems were designed to carry indefinitely. That signal deserves to be heard gently and taken seriously. By now, the intellectual answer to this video's central question is fully visible. Dreaming exhausts because the brain is genuinely working. Stress makes that work harder and less efficient. Sleep architecture, when disrupted, fails to complete the physical and emotional restoration the body needs. And the nervous system that processes dream life cannot fully distinguish that experience from waking life. All of this is science. But what the science points toward is something quieter. The morning tiredness after a hard night of dreams is not a sign that the body has failed. It is the evidence of a mind that has been trying, in the only way it knows, to take care of you. That understanding, carried gently into the night, is the beginning of a different kind of rest. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your breath rises and falls. Your heartbeat marks time in its quiet rhythm. Your brain, even now, is beginning to shift from waking towards something softer. Like your breath. Inhale. Exhale. Inhale. Exhale. A small cycle within the larger one. You don't need to hold on to any of this. Let everything unfold in its own order, like something moving without effort, turning without resistance, simply existing. We're almost there now. The night holds more than we know. Every person asleep right now is somewhere in their own cycling journey, moving through stages, through depths, through images that will be gone by morning. The body begins preparing for sleep hours before the eyes close. Core temperature dips. Melatonin rises. The breath slows, almost imperceptibly. Sleep is not an event. It is a gradual arrival. Every dream that has ever been dreamed existed nowhere but inside the brain that created it. And yet it felt completely real. The capacity of the mind to generate experience is one of the quieter wonders of being human. During a single night, the average person spends roughly 90 minutes to 2 hours in REM sleep. That is 90 minutes of vivid, emotionally active inner life, occurring in a body lying completely still. Deep sleep is the body's gift to itself. The hour or two of slow-wave sleep that arrives in the first half of the night repairs tissue, consolidates learning, and clears the brain of the day's accumulated residue. The sleeping brain does not know it is sleeping. From the inside, the dream is simply experience. The discovery that this experience is internally generated remains one of the most philosophically interesting findings neuroscience has ever produced. Unease in dreams is not a malfunction. It is the brain doing exactly what it evolved to do. Rehearsing, preparing, testing responses to imagined scenarios. The safety of sleep is the space in which the mind can practice. Children who sleep well learn more readily, regulate their emotions more smoothly, and show greater resilience in the face of everyday challenge. Sleep is not separate from development. It is woven through it. The emotions felt in dreams influence waking mood in measurable ways. A dream of warmth and connection can leave a lingering sense of ease. A dream of loss or conflict can leave its shadow across the entire morning. The dreaming mind is the waking mind's closest neighbor, and its weather crosses the border. The resting brain, like the resting body, is not truly resting. It is consolidating, integrating, maintaining. The stillness of sleep is only visible from the outside. From the inside, it is an unceasing and elaborate process. Some of the most quietly profound insights in history have arrived through sleep. The associative, non-linear quality of the dreaming mind, free from the constraints of sequential reasoning, is precisely what allows it to find connections the waking mind tends to organize away. The soft weight of blankets, the quiet of a room at night, the familiar sounds of a sleeping house. These sensory cues become associated over time with sleep itself. The brain learns to slow down in their presence. Comfort becomes biological. The sleeping brain monitors for safety without fully waking. A parent hears their child stir through the deepest sleep and surfaces immediately, while a louder, unfamiliar sound does not disturb them. The brain is always listening. It simply chooses what to hear. Forgetting is part of sleep's design. Most dreams dissolve within minutes of waking, and researchers believe this forgetting is functional, preventing the dreaming brain's loose associations from overwriting the structured, reliable memories of waking experience. The exhausted morning after a dream-filled night is not the sign of a night wasted. It is often the sign of a night well used. Emotionally, neurologically, biologically, the body that wakes tired from vivid dreaming has not failed to rest. It has been somewhere, and somewhere costs something. The science of sleep is young. Formal sleep research is barely 70 years old. What has been discovered in those 7 decades has overturned almost every assumption the previous centuries held. What remains to be discovered is, in all likelihood, equally transformative. The boundary between sleep and waking is not a sharp line. It is a gradient, a spectrum of awareness that shifts gradually as the night progresses and the morning approaches. The moment of waking is not an arrival. It is a slow surfacing. In every language that has ever been spoken, humans have used the same metaphors for sleep: falling, sinking, drifting, letting go. Across cultures and millennia, the body's experience of descent into sleep has generated the same felt sense, the same instinctive language. We are all going to the same quiet place. The brain you will wake up with tomorrow is not quite the same brain you have right now. Sleep will have edited it slightly, strengthening some connections, softening others, clearing away what is no longer useful. Each morning is a new version of the mind, shaped by the night that made it. And the last fact of this journey is the simplest one. You cannot force sleep. You can only create the conditions in which it arrives. Warmth, quiet, the gentle release of the day's remaining grip, the permission offered to yourself, freely and without condition, to simply be here, in the dark, and let the night do what the night knows how to do. And so, our quiet journey through the science of dreams and the exhausted mind comes to a gentle close. We traveled from the first discovery of REM sleep, those rapid eyes moving beneath closed lids in a laboratory in 1953, to the glymphatic rivers that flow through the sleeping brain, clearing the residue of waking thought. We passed through the amygdala, working at full intensity in the dark, through the norepinephrine that must fall before emotional softening can begin, through the ancient circuitry that mistakes the dreamed experience for the lived one. We glimpsed what the exhausted morning actually is. Not a failure of rest, but the afterimage of a mind that worked through the night on your behalf, in silence, with great care, and without asking permission. Dreams remind us that the mind has its own agenda, one that does not always align with our waking intentions. Much of the most important work the brain does happens below the surface of awareness, in the hours when we are least present, in a language of image and feeling that waking thought cannot quite translate. Without dreams, something essential would go unprocessed. Something would accumulate that has no other way out. By pausing to understand this, even gently, even incompletely, we give the sleeping mind a kind of dignity it rarely receives. In these final minutes, take the deepest breath you can as deep as possible. Think about unity of every signal, every memory, every processed feeling that has moved through a dreaming brain somewhere in the world tonight. You are not the only one. You are not alone in this. Think about the dreaming mind releasing the day, not erasing it, but softening it, transforming it, deciding what to carry forward and what to finally let dissolve. You too can dissolve into sleep like that. No boundaries left between you and rest. Let your entire being settle into the quiet that comes after understanding, into the dark that is not empty, but full of the mind's own peaceful turning. Prepare for deep sleep. No more questions. Only peace. This thoughtful exploration of the dreaming mind has hopefully brought you a little closer to rest, and a little more understanding of what the sleeping brain does for you each night. A quiet like or subscribe helps other exhausted minds find their way here too. One soft tap, one sleepy soul at a time. But there is no need to do anything now. Nothing at all. You have traveled far tonight, not across miles, but inward, through the architecture of the sleeping brain, through the chemistry of emotion and memory, through the quiet science of why we wake the way we do. You can allow these thoughts of dreams and sleep to fade now, like the last image of a dream at dawn, present for a moment, then softer, then simply part of everything, leaving only the still, unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if all the thinking has settled gently downward and is simply resting beneath you now. If sleep comes, let it carry you the way the night always has, not rushing, not forcing, but arriving in its own time, in its own way, into a place where nothing more is asked of you. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the brain will still be at its work. The cycles will still be turning. The glymphatic rivers will still be flowing through the sleeping mind of someone, somewhere, doing exactly what they were made to do. But tonight belongs to stillness. Rest well, sleepy soul. And remember, the mind that dreams is the mind that cares. Good night.